with the exception of some Sprites talks we're going to do today to get people aligned on this, but bear with me for a moment.
Okay.
And in this folder, go ahead.
No, I was just saying okay to the original question. I think I'm clear. Thank you.
Okay, good. So I just wanted to say what I've taken so far is if you look at the game folder, it's going to look a lot like the layout that we had for our last game. In fact, I took the last game and I stripped out all the parts I didn't need and left behind just a skeleton. So the last game was Monsters Need Coins. So that had some stuff already laid out for us. It had a common it had a common Lua. It had it had a sound Lua. So all that stuff is the same in the sense that it's the same files, and we're going to fill them in with different content. So it's very similar to the layout of our last game. There's a game Lua, which is the master one file for sort of setting up the game and producing all the right things at the right time to set up a level.
And you do that for efficiency's sake, right? So that you know
Yeah.
that the next time that you put something together, or if you look back at some of your previous work, you're like, oh yeah, I know exactly where to find my files. I know what they're named. I know what they do.
Right. And I'm trying for as much as possible for the people who are watching these shows. I'm trying for consistency. I know that it's been sort of an up and down path here, or back and forth, however you want to think of it. But I think as we go along, the consistency will get better as far as how these games are laid out and structured. I can't keep them completely consistent because not all games are alike, but the major things like sound.lua and common.lua and game.lua, I can do that. That's definitely doable. So we're going to do that, and people will be able to quickly follow along as they do more and more of these shows and follow the code.
Okay. Yeah, and to be fair to you, there's probably a big difference between putting projects together for publishing a game than trying to put together the projects for walking people through the concepts and demonstrating how the code works. Right. So it's
Absolutely. In fact, I would not even do some of these games quite the way I'm doing them, but I do some of these things a little bit longhand or split them out because otherwise it's just too hard for people to track and follow. And what's the point of doing it if people can't follow what I'm trying to show them? So last week, I don't want to spend a lot of time on this, but last week we talked about using the Reiner set, and I kind of gave a hint at, here's how you set up the sequences, and I said, here's some code to auto-generate a sequence without explaining what a sequence was. So this week, I'm going to show you what a sequence looks like longhand, and then quickly show you the generator again so you can see what's going on. So here, what we've got is the character from our last game, our main character. And as you can see, he's running the same animation using different timescales. And this animation is called right walk. Now, to set up this code, what I did is I took all these textures, which you see on the screen, and I put them in a sprite sheet using Texture Packer. So I just dumped them in Texture Packer and then exported to a file called Pinky. And then Texture Packer exported this sprite sheet and exported this Lua file, which contains information about the sprite sheet, including a list of frames, pardon me, including the location of the start of each image, how big that image was, etc. And then if we scroll down here, it has a short list of the names of each of the original textures and the frame that represents that or is that texture. So frame 1 is the jump texture, frame 2 is the stand, frame 3 is the first texture that goes in the walking animation, and there are 11 frames in the walking animation between 3 and 13. Now, this is a very short list. It's tractable in the sense that I can read it, understand it, see it all on one screen. So I don't need help creating a sequence. And when I say a sequence, what I'm talking about is this data right here, which is basically a table of tables where each subtable is outlining the details of a specific animation. For example, the idle animation has one frame, and that frame is 2. And if we look at our previous file here, that means we're going to use the standing texture, which is frame 2. And then the time doesn't matter because it's looped. It's only one frame, so you won't see any transition. So I just put the default of 1000. And a loop count of 0, which means it runs forever. Again, one frame, it doesn't matter. I could have put 1, 2, 3. You wouldn't notice the difference. And then a loop direction of forward, which means that it plays sequentially from the lowest ordered frame to the next one to the next. Similarly, the jump animation for this character was just one frame. So I have another table which is called jump, or it has an entry called jump. It has one frame, which is the first frame, which is P3 jump. And the same details on the time, loop count, loop direction. Now the interesting ones here are right walk and left walk. So right walk has a frame set that starts at 3, ends at 13, and I just typed them out. Now, if I had wanted to change this up and maybe goof around with the animation or change the sequence, I could do that. I could put these frames first. Now, when I run it, it'll probably, yeah, so it looks a little bit different. It may be pretty subtle, but I would expect people to take a look at this code later and just mess with it and see what they get. But you can't really see it. But the frames have now, the sequence has changed, and it's interesting. It looks more like he's doing a skipping or something. So
yeah, some weird jumping jacks, yeah.
So put that back. But the point is, this is very easy for me to write. I can understand it. It's no problem. But the writer set, on the other hand, had what, like 300 frames with all kinds of weird names, and 10 for this animation, 15 for this animation, 3 for the other animation. There was no way that I was going to type that up by hand and go back and forth looking at this file and going, okay, the next one is 10, the one after that's 22. You know, there's no guarantee they're going to be in order. They just get put in the list in any order the texture packer wants to. So what I did instead, we will just look at it again briefly. Let's load it up first so you can see it. So this is in 4 sprites, and then there are 2 subfolders, one called simple, the other one called complex. We just looked at simple. This is complex, and it's got the red zombie, and what we're seeing here is it's played in different scales and different directions. So this one's pointing down at an angle, this one's doing the attack, this one's getting hit, and this one is being destroyed over and over. And then finally the bottom one is walking, and I just randomly change the direction it's walking in every couple of seconds. But let me bring up the code. So we can see how much harder this is, or would be, to do if okay, so for this animation, we've got a sprite sheet with, I don't even know how many sprites this is. It's
a lot.
304 frames.
Good grief.
There's no way I'm going to go through this list, even if it's in English, because not all of them are in English for Reiners. So you've got to be like, it's in German. What's that word? I can't remember. But I'm not going through this list and typing out by hand every single animation sequence. Instead, what I've done is I have created a tool that generates that sequence. And it does it by having me pass in certain details, saying this subsequence name pointed in the north direction. And what it does is it creates these names. It composites these names. So, for example, if I passed in walking north as the sprite that I wanted to make, the sequence I wanted to make, it would be called walking here. That part would be replaced with that, and then north, and then for each frame it would be 0, 0, 1, 2, 3, 4, etc. It does all the math, all the combining, and generates a table very much like the one we saw, but using an algorithm.